Okay, a bit more about first ionization energy and the evidence that it provides for the existence of subshells. The reason I'm doing another video on this because it is very much what they ask, or the exam questions are always on these. Now let's have a look at I've got my little periodic table at the top up there, just have a look at that, okay. And I've done period 1, hydrogen, helium in green, so there they are, green, yeah. And I've done the period 2 I've done in blue, and period 3 I've done in red. And you can see the pattern that you get here with the period 2 is repeated with the pattern you get with period 3, almost exactly. There's obviously reasons for that, which you probably know already, but we'll talk about them. Okay. Now let's just think about, first of all, what's happening as we go across either of those periods. Let's say we're going across period 2. What's the what's happening? The general trend is the ionization energy increases. There's a couple of blips, but it goes up. Why is that? Okay, so across period, the first ionization energy increases. Why? Right, nuclear charge increases, doesn't it? But also what's happening there is atomic radius also decreases. A lot of people don't realize that, but as you go across a period, atomic radius decreases because there is a greater nuclear charge and it holds the electrons in stronger. So there's two factors going there. Ionization energy increases because you have got more nuclear charge and it's getting smaller. Yeah, the atoms are getting smaller. So that's pretty important. Let's have a look at some other things that we might see there. Right. We have this blip here. We have a blip from beryllium to boron and from magnesium to aluminium. Okay, so decrease beryllium to boron and magnesium to aluminium. Well, the reason for that is because you're not removing the electron from the S shell as you are with these ones. You are now removing the electron in those from the P shell. In that case, it's 2p. In that case, it's 3p. But and the P is a little bit further away from the nucleus than the S. So that accounts for that little thing there. Now the other little blip you get is, of course, here between nitrogen and oxygen, and between phosphorus and sulfur. And if you go back to the reason for that is because the electrons, so let's write that down. So what we're saying, nitrogen decrease, nitrogen to oxygen, and also from phosphorus to sulfur. Same reason is because the electron is this pair repulsion. Yeah, the electron you're removing is paired, and so it's a bit easier to get rid of. Okay, so I'm going to start running out of a bit of space here. Now, what else can we notice? What is at the top of those? What's at the top of those? The peaks every time. We can see we've got helium, we've got neon, and we've got argon. Noble gases, yeah. Okay. Now, what's the reason for that? I'm just going to start getting a bit messy here. Right, noble gases. At the peak, why? Well, they've got the highest first ionization. Well, because you've got maximum nuclear charge for that quantum shell. Okay, so i.e. for helium, it's got the maximum nuclear charge for quantum shell 1. For neon, it's the max nuclear charge you can have, and it's still have quantum shell 2. And for argon, it's maximum nuclear charge for quantum shell 3. Let's just have a look at argon, right? When you increase the nuclear charge any more than that, you immediately move down not from quantum shell 3 to quantum shell 4, so it's a lot further from the nucleus, so you get a drop. And the same reason, just saying there, is that you get the alkaline metals are at the trough every time, aren't they? Well, why are they down here? So look, you've got lithium, the bottom there, sodium and potassium. Why are they at the bottom? The reason is because you have got the minimum nuclear charge for the quantum shell. Okay, so that's that. What you should also, and it's not really apparent from my graph there, is can you see that, right, it says helium is a bit higher than neon, which is a bit higher than the first ionization argon. Argon, it doesn't quite look lower, but it should be. Okay, as you go down any group, the first ionization energy increases. So if you look at lithium, it should be a little bit higher than sodium, which is a little bit higher than the potassium. It should be, not that clear on my diagram. And why is that? Well, it's because as you go down a group, what causes the size of the first ionization to drop? Well, it's not obviously not the nuclear charge, because that's getting bigger, isn't it? But it's these two things. The distance from the nucleus and the shielding is increasing as you go down the group. Okay, so hopefully that you should have all of that fairly well in your head now. And don't forget this little pattern, this repeating pattern you get for periods 2 and 3 with the two little drops. You should be able to explain those.